Good morning, everyone. I'm excited to welcome you to our presentation today. We're here to introduce Guardian Drive, a smart alcohol detection and access control system. This innovative solution aims to enhance road safety and ensure smarter, responsible driving. On this first slide, you can see the title, Guardian Drive, Smart Alcohol Detection and Access Control System. And right below, our team from Nagercoil, encouraging everyone to drive safe and stay smart. Over the next few minutes, I'll walk you through how our system works, its features, and the positive impact it can have on road safety. So, let's get started and explore how Guardian Drive can make a difference. Let's take a closer look at the problem we're addressing today. First, why does this issue really matter? Well, alcohol-impaired driving continues to be one of the leading causes of fatal crashes on our roads. Despite awareness efforts, many drivers still underestimate how impaired they are and attempt to drive anyway, which significantly increases the risk of accidents. Now, when we consider the current gaps, it's clear there's a lot of room for improvement. Most vehicles today don't have simple, affordable checks that can be done before starting the engine. Imagine if the car could detect impairment and prevent ignition if necessary. That could be a game changer in reducing these tragic incidents. Connecting this back to our overall goal, addressing these gaps is essential if we want to make our roads safer and save lives. Our solution, overview. Guardian Drive is an innovative in-vehicle system powered by Arduino, designed to promote safety and responsible driving. It performs a breath alcohol check before the engine can start, ensuring that the driver is sober. If it detects alcohol, it immediately blocks the ignition, preventing the vehicle from starting. At the same time, it triggers both audible and visual alerts to grab attention and communicate the issue clearly. To add an extra layer of safety, there's a built-in reaction test that allows sober drivers to prove their readiness to start driving. This test helps confirm that the driver is sober and alert before the vehicle is operational. The system uses a pre-start breathalyzer, specifically the MQ3 sensor, to measure alcohol levels accurately. It controls the ignition relay, effectively managing whether the engine can start or not. The reaction test provides a way for the driver to override the system if necessary, but only when sober. Finally, it offers clear feedback through LED indicators and a buzzer, making the system's status easy to understand at a glance. Overall, Guardian Drive integrates these features seamlessly to enhance road safety and prevent impaired driving. Let's walk through the working process step by step. First, when the driver approaches, they sit comfortably and provide a breath sample using the MQ3 sensor. This step is crucial because the sensor needs to warm up to stabilize its readings, ensuring accurate detection. Next, the system checks the alcohol level in the sample. If the level exceeds our set threshold, it immediately prevents the vehicle from starting. At the same time, you'll notice the red LED blinking and a buzzer sounding. These are clear signals that alcohol impairment has been detected. If the alcohol level is below the limit, the system then prompts a reaction test. This is a timed, button-press test designed to assess the driver's responsiveness. Quick and accurate responses here can allow the vehicle to proceed, confirming the driver's alertness. Finally, once all previous checks are cleared, the system controls the ignition. The relay either opens or closes the ignition circuit, acting as the gatekeeper. Only if all checks, alcohol level and reaction test, are passed will the relay enable the engine to start. This step-by-step process ensures that the vehicle only starts when the driver is sober and alert, tying directly into our overall goal of promoting safer driving. Let's take a closer look at the hardware and components that make this system work. First, we have the Arduino Uno, which acts as the brain of the operation. It controls the logic, manages timing, samples data from sensors, and switches the relays as needed. It basically coordinates everything behind the scenes. Next, there's the MQ3 alcohol sensor. This is a low-cost semiconductor sensor designed to detect ethanol in a person's breath, making it ideal for our alcohol detection system. It provides real-time feedback on the alcohol concentration, which is crucial for safety. Then we have the relay module. Its role is to isolate and switch the vehicle's ignition circuit safely. Since the Arduino operates at low voltage, the relay allows us to control the high-voltage ignition circuit without risking damage or safety issues. Finally, the system includes indicators and controls, LEDs that show the system's status, a buzzer that sounds an alarm if needed, and a push button for the reaction test. All of these are powered by a DC supply, ensuring the whole setup remains operational and responsive. Together, these components form a cohesive system that effectively detects alcohol levels and safely controls vehicle access, aligning perfectly with our goal of enhancing safety and automating vehicle security. In this slide, I want to walk you through the prototype circuit and the software logic we've developed. We start by pairing simple hardware components with a robust embedded software system. This allows us to handle sensor warm-up and calibration effectively, ensuring accurate readings right from the start. We also implement a moving average filter for alcohol sensor smoothing, which helps reduce noise and provides more reliable data. Threshold gating is used to determine when alcohol levels are significant enough to trigger an action, and we have a timed reaction test window to ensure safety during operation. A critical part of our system is the safety-first ignition state machine. This ensures that the ignition only activates under safe and tested conditions. On the software safeguard side, we debounce button inputs to prevent false triggering from accidental presses. We also require multiple successive low readings before enabling ignition. This adds an extra layer of safety by confirming the sensor readings are stable and truly indicative of the intended state. And of course, our default fail-safe setting is to keep the system locked, preventing any unintended activation. All of these elements work together to create a reliable, safe, and user-friendly system that aligns with our overall goal of safety and accuracy. Let's take a look at some of the exciting future enhancements we're planning. First, IoT alerts. This feature will enable the system to send notifications to family members or authorities if it detects repeated attempts to start the vehicle while the driver is impaired. It's about adding a layer of safety and ensuring help can be quickly mobilized if needed. Next, we're considering secondary tests, like simple focus or balance assessments. Think multi-tap patterns or other quick tasks. These tests will help reduce false positives and give us a more reliable way to confirm whether the driver is truly alert or impaired. Moving on, improved LCD and user experience are on the horizon. We want to provide clear, easy-to-read messages along with real-time blood alcohol content estimates directly on a compact LCD. This gives immediate feedback to the driver, helping them make informed decisions. Finally, we're working on transitioning from our current breadboard setup to a custom PCB. This move will enhance reliability, make it easier to mount the system in vehicles, and facilitate mass production, bringing this technology closer to real-world deployment. All these enhancements are aimed at making our system safer, more reliable, and more user-friendly, tying directly into our broader goal of reducing impaired driving and saving lives. Let's talk about the impact and feasibility of Guardian Drive. Our main goal is to achieve measurable safety improvements, specifically by reducing drunk driving incidents. We do this by offering an affordable, passive pre-start barrier that's easy to use. One of the key advantages is that it has a low bill of materials cost and straightforward integration, making it practical for a variety of vehicles like bikes, two-wheelers, and cars. When we say affordable components, that means we can scale this solution widely, reaching more drivers and having a bigger safety impact. The quick installation process is another highlight. It's relay-based and non-invasive, so it can be set up with minimal effort and no major modifications. And finally, the behavioral nudge is crucial. By providing immediate feedback, it discourages impaired driving right at the moment when the driver is about to start. Altogether, these elements underscore how Guardian Drive is not only effective, but also feasible for widespread adoption, aligning with our mission to make roads safer for everyone. Thank you so much for your attention. I want to take a moment to express my gratitude to Team KV Nagercoil for their dedication and hard work throughout this project. Their commitment has truly made a difference. And of course, a big thank you to all of you for being here today. As we wrap up, I'd like to highlight Guardian Drive again, our initiative focused on making roads safer, one vehicle at a time. It's all about reducing accidents, saving lives, and creating safer communities through innovative technology and teamwork. Now, I'd love to hear your questions or thoughts. Please feel free to ask anything or share your feedback. Thank you once again for your time and interest.